So welcome to my work solutions for the Edexcel Higher GCSE. It's November 21, doesn't say it because they're probably a little bit unsure of when they might do the exam, with it being the tail end of COVID, but it's paper 2, so let's shut up and get on with it. So some laws of indices to begin with, in a phrase in a weird way, but it's all the same. When it's multiplied, you add the powers, that should be power of 9. Power inside a bracket raised to another power, so you multiply the powers. 3 times 7 means it's 21, or if you've written 5 to the power of 21, the mark scheme does say that's acceptable. Strange one here, you can leave it as it is. I personally multiplied both sides by 7 to the power of p, so the powers on the left hand side, you add them to make 10. The powers on the right hand side, it's multiply, so you add them. Whoops, I'm writing the answer, aren't I, like a dipstick? And so you know quite clearly, and you could have worked it out without doing that. As long as you get to the right answer, who cares? Number 2, two rectangles. As soon as you see the word area, start multiplying. So rectangle A, when it says show, I do like to show this line of working out rather than having it jumping straight into expanding and writing 20. There's plenty of time for that. It's a 4 marker. You've got about 5 minutes. No rush. 5 minus x. So that is the formula, however you want to call it, the expression for rectangle A. The area of rectangle B is twice, so we need to double that to get the area of B. And now it's a case of expand and solve. You've set up the equation. Let's get it solved. So 8 times 5 and the 8 multiplied by negative x. Over here we get a 10x minus 5. Isolating the x's, I'll take a plus x across, plus 8x, and plus 5, giving us this. So x will equal 45 over 18, cancels to 15 over 6 if you try, or 5 over 2, or 2.5, all perfectly acceptable. Number 3, bores me writing these out every time, so I've done it already so you don't have to watch me scribble. You're estimating, so you write down the midpoints wherever the heck you want. You multiply them by the frequencies. They usually, as this one's done, they usually give you a clue by moving the table across to the left. So midpoints, sometimes referred to as x, multiplied by frequency, you get your fx's over here. And when you sigma or sum your fx's, you should get 1,488. That then needs dividing. Number of times students think it's divided by 5. No. Divide by the number, the total, the sigma f, whatever you call it, and we get 21.257. And to do as you're told, that's 21.26. I'll go back now and do A. Finding the probability, we're choosing from all of the amounts, so it's out of 70, and it's those who spent more than 24 euros. It's the bottom 2 groups who were 24 or more. So 31 out of 70. Don't even think about writing that as a decimal. Number 4, similar triangles means there is a multiplier. So whether you whether you write your multiplier as a fraction or a decimal, no one cares. But I do 45 divided by 20. So my scale factor is 2.25. So I'm multiplying or dividing, depending on which way around I'm going. To find AB, that's that one there. The corresponding side is 36. So it's 36 times 2.25. In goes 81. And to work out EF, it's the other way around. You're told that that's 54. And when you do the 54, you divide it by your scale factor. 54 divided by 2.25. Let's get it on the screen. Gives us 24 centimetres. On we go. We have internal external angles of regular polygons, not the pentagon, but of the octagon. So of external angles is 360 divided by the number of sides. So that angle on this octagon is 135. We're not actually interested in that. What we do want is the internal angle. That side there. Obviously, there's a slightly longer way of doing that, but as long as you get that to be 135, it's all good. So internal angles, and you might just know that off the top of your head. If so, well done. Over here to the irregular pentagon. So inside a pentagon, there's 3 triangles. Again, you might not need to work that out. You might already know that it's 3 180s. So their total is 540. So if you start with 540, you subtract each of those numbers, you end up with 230. So when you halve it, that's the angle you're after. That is 115. That now gives you enough information to work out x. Angles around a point make 360. So you do x and you subtract the 135 and the 115, which you have found, for a nice 5 marks. Number 6. Victor selling is one of those percentage profits, so don't forget the formula. It's actual profit divided by original amount multiplied by 100. That comes up very, very often. What we do know is that he bought 12 for £21, so we already know the original outlay. What we don't know is how much Victor made. So 12 times $2.45 will tell us his takings were 29.4. Subtract what he spent means he made 8.4 profit. Get all that stuck in your calculator. Out comes a nice 40% for our answer. Number 7, extremely wordy. At the end of the day, it's the old capital and multipliers and work out each bank in turn. Why they bother with all the waffle? You only need to look at the table. We've got Cyclone Bank, 25,000 capital. Interest is compound, so multiplier, or a load of rubbish, is 1.045, and it's for 3 years. Get it to the power of 3, and that would give you 28,529. It wants nearest dollar, so let's go no further than a couple of decimal places. Now we do Tornado Bank. No need to work a great deal out here. It's 25 grand, and there's no percentage. It's simple interest. It's $1,150 each year, so it's 3 lots of that. And your calc should give you 28,450. How much more? That means difference, which means do a subtract. 79.15-ish, but obviously we're wanting nearest dollar, so that will be 79. On to a bit more laws of indices. For part A, anything to the power of 0, I don't care what it is, it's 1. Part BI, we are factorising a quadratic. Your job is to think of pairs of numbers that multiply together to make minus 36, but add together to make negative 5. Feel free to list them, minus 12 and 3 and so on, but they don't add together, they just multiply. So eventually you'll zoom in and get minus 9, positive 4, and when you solve a quadratic, it's about changing the signs. So we get positive 9 and negative 4 for our solutions. Number 9, big standard form and sticking it in your calcs, really. Work out the number of bacteria per raindrop. So what you need is 1.75 times 10 to the power of 6. That's how much bacteria the rainwater tank contains. And if you want to find it per raindrop, that's why you are dividing by the number. Because if you're working out, how much are we sharing, how much of this money will these 3 people get, divide by 3. So how much bacteria does each raindrop have? Divide by the number of raindrops. That's why I'm hopefully getting across why it's not the other way around. Your calc will give you 7/96, but to 2 significant figures, 0.0, they're not significant. 729-ish are, so it's 0.073. Next one, again, more waffle. Ultimately, drop of rainwater contains that many atoms. In a drop of rainwater, the number of atoms is 3 times the number of molecules. So we have the 2.4 times 10 to the power of 7. That's from part A. That's how many raindrops we have. Each raindrop has that many atoms, so it needs multiplying by that. But that's not the full answer yet, because it doesn't ask. That sum there will give you the number of atoms in the rainwater tank. We're wanting the number of molecules. All right, and it's 3 times the number of molecules. So to get, you have to divide it by 3. All that comes out to 4.008 and 10 to the 28, one significant figure. So take it down to 4 and you're done. Number 10, isosceles triangle. They put the markings on quite helpfully. They tell us a few things. What we're really after, though, is the hypotenuse, because if you want to work out the perimeter of a triangle, it's the distance all the way around. Well, the 9.3 does tell us it's perpendicular, midpoint, isosceles, and all that malarkey. So we already know that one. It's a case of if we knew the hypotenuse, we'd also know it over here because it's symmetrical. We have an angle, we have the adjacent side, and we want the hypotenuse. It's a cat. We get our hypotenuse by doing adjacent, 9.3, over cos of the 38. 11.80, that's 4 significant figures. It wants the final answer to 3. So our job is, on your calcs, double the 9.3 and add it to double of 11.80, giving you 42.2 centimetres. Number 11, better circle theorems, all that malarkey. At the end of the day, I'm so glad it doesn't say give reasons, because I dislike those questions. So we don't need to give reasons. We can do all your working out on the diagram. OB is a radius, which means it's perpendicular to the tangent. So angles in a triangle make 180. We know that that is 42. We can actually shove that in there. That's rubbish. meant to be a straight line. Let's just... OB is a radius, OD is a radius. So I'll change pen colour just to make it clear. That angle there and that angle there are base angles of an isosceles triangle. So if you do 180 minus the 42, get your answer and halve it. That tells you each of these is 69 degrees. We're nearly there. So to get angle DFE, that is that angle there. As you can see, people, using E and D, you can create F, and you can create that 69 there. So this is the old angles on the same arc are the same, and I'm just quoting it just because it's always good revision, but that's the reason why that angle happens to also be 69. 12A, more laws of indices. They do love it. Each thing in turn, you've got 64 that needs sticking in your calc to the power of 2/3. So you cube root it to get 4, square it to get 16 without your calc, but your calc is your best friend. But now we've got fractions multiplying, so 9 multiplied by 2/3 means P has the power of 6. 12 times 2/3 means Q has power of 8. On to part B. Algebraic fractions. You could go for anything, 60x and so on. You need to go for the lowest common multiple, really, which they all go into 30x. On the first term, that would mean you're multiplying by 10. Do the same to the top. Middle term is times 5. And final term is multiplied by 3. And it all simplifies on the top. So the numerator is 17. Denominator stays at 30x. It does not simplify. You've done a little bit of simplifying. It's only worth 2 marks, so it was never going to be a massive one. Part C is expanding a cubic, but it's not 3 brackets. I usually say pick your 2 brackets first and crack on and do a grid. Not when it's just a 4x. I would simply expand these brackets. So the x squared term is 2x squared. The number term is minus 15. And I always do the x's in my head and simplify it as we go to save a line of working out. So negative 10x plus 3x means we end up at minus 7x in the middle. And now everything needs multiplying by 4 and an x. So we get 8. And the x goes to cubed. We get negative 28. The x goes to squared. And we get negative 60. With just an x on the end. Number 13, one of them where they've drawn the inequalities for you, so always worth having to think about what inequalities are we given. Thankfully, the hardest one they've already given us. This diagonal one does the old goes through common numbers on the x and y axes. In other words, the coordinates are 0, 1 and 1, 0. They always add up to 1. Then we have this horizontal line down here. Horizontal lines must be of the form y equals the number where they intercept. In this case, negative 3. And now you've just got to define your regions. So for this one, the height, in other words, the y, is underneath that line. So y is underneath 2x plus 2. I can now scroll down and get rid of that. On this one, the height needs to be above negative 3. So we'll say that y must be greater than or equal to minus 3. And for this one, it's kind of underneath, as I would say it. So again, the height doesn't need to be too big. So it's the x and the y's which would need to be under 1. And there we go. Number 14. Love these histograms in the middle of the paper. Absolute gold mine. Do not rush them. Take them nice and easy. Remember, frequency means area. And yeah, I've already drawn it because it just takes too long. I am rubbish with technology. Haven't you learned that yet? I always make a note of the widths because ultimately histograms are just areas of rectangles. To find the frequency densities, which I always refer to as height. Area divided by width gives you the height you need to draw. Track on with that on your calc. 1.9, 1.6, 0.3. And when I'm drawing them, I always put notches first for the widths before I then start drawing in the heights one by one. Do use a ruler, it just looks so much better and gives you more. Yeah, it's just better, isn't it? Have some pride. Select a random flight that was late by 25 minutes or less. Okay, so 25 minutes or less is luckily these here, because they're up to and including, so just under, up to and including, up to less than 25. So we add them up. We know that our probability, therefore, is out of 40. This will now explain the purple line, work out an estimate, and it's only an estimate because we assume the data is evenly spread, that it's 5 minutes or less. So the purple line is where 5 minutes is, the area of the first bar is 8, and the purple line chops it in half. As we've said, it's an estimate. We assume they're evenly spread. Yep, they could all be grouped up at 9 or down at 1. It's a guess, hence an estimate. So it's 4 out of 40. No need to cancel it down. Number 15, some early functions. 6 marks, big deal. I know some people hate functions, but it is what it is. There's always that easy mark where here you do not want to be want to be dividing by 0. So the value of x, which would make the denominator 0, is negative a third. Part B, compound functions, in other words, posh substitution. You are attempting to put the formula for f into the formula for g. And as you can see, that means it goes into 2 places. It goes into the numerator, replace the x with the f of x, and on the bottom, there's more to it. There needs to be a 3 in front, and there is still a +1 on the end. So nothing will simplify on the numerator, but on the denominator, you'll have 3 lots of 2x, and you'll have 3 lots of -3, -9, but then add the 1. And that's, again, it's only worth 2 marks, doesn't simplify. Part C, they always happen. They love these inverse functions of awkward functions, and they never give me enough room. My writing's always a bit too jumbo for it. But anyway, the method is let x equal the function, let y equal the g of x. I'll get it right in a sec. And rearrange to make x the subject. So we multiply both sides by 3x plus 1. Whoops, I want to skip a line here. So y times 3x and y times 1. And now we need to isolate the x's. You could get them on the left or the right. It just means your answer will have minuses where I have pluses and vice versa. Mark scheme does not fuss. It's happy with either. I'm going to go on the left-hand side. So take away an x, while also subtracting a y. This is the point where you factorise. Take an x out, and you've now got your x equals, it's negative y over those brackets. But that's not how your answer looks. I'm sure your teacher has nagged you. The final step for inverse functions is your y's become x's, your x's become y's, for reasons I'm sure they've gone into that you've now forgotten. So for now, just go with it. It's minus x over 3x minus 1. Or as I say, if you group your x's to the right-hand side, all signs will change. Number 16. Don't get put off. It's not as bad as you think, this one. Truly. Looks waffly. People don't like waffly, big, long-winded probability questions. It's actually not that bad, folks. Box contains 15 counters. Red is 4. Green is 5. The rest are yellow, so that'll be 6 then. Work out the probability. So you pick one, then we pick another. You'll notice it is replaced. Sasha takes it at random. Sorry, he puts it back in. So it is replaced. What's the probability of the same colour? So we're interested in red, red, green, green, y, and they will all be added. So red, red is 4/15 times 4/15 because the counter is replaced. Green, green, 5/15 multiplied by 5/15. And yes, you've guessed it for y, it's 6/15, and the probability that the second person gets, it doesn't change. 6/15. Again, stick it all in your calculator, and that's why it's only 3 and not a big 4 or 5er. It's just 77 over 225. Number 17, we've got nice rationalising. As some of you will hate surds and probably just skip the question, but I certainly wouldn't. You've got plenty in this for 3 marks to do, but it's all nice and relatively straightforward because you need to multiply top and bottom by change of sign, so the minus becomes a plus. And when you do top times top, I would argue that's easy enough. And when you do bottom times bottom, you only need to do the root 5 times the root 5 and the negative 1 times positive 1 to get 4. As you can see, everything in the numerator divides by 4, so we can make it all cancel down to 2 root 5 plus 2. But here's the problem. That's not the answer. It doesn't say that you have a number in front of the surd. We need to do something with that 2. So we need to use, when you split a surd up, for example, root of 36 times root 2, as in root 72, you can split them up into separate surds. So we are going in reverse, but in order to do that, we have to square the 2. So the 2, another way of writing the number 2 is root 4. That means we can combine them by multiplying, and so the A is 20, not 5 and not the 2 before. Just be careful on that one. It's not a bad question, but it is sort of phrased in a way designed to catch you out for a mark, certainly. Number 18, I'd argue it's pretty obvious, double trigonometry. The only question is it sine rule, cosine rule, or both? It's both, but is it one of each? And so on. Always look for the line they share. No point in carrying on. The line they share is always a target. So let's do that before we read the question. we can say that AC squared, because it's, as I've not mentioned, it's the cosine rule because we have an angle and the two sides either side, we don't have an angle and the side opposite. So it's AC squared equals the two sides we know squared and added minus two lots of the sides we know multiplied and all multiplied by cos 60, which actually is just a half. So it all works out to be 117. And so this AC is the square root of 117. Now it turns out, my little speech at the beginning, it's not actually one of each. It's sine rule or cosine rule, or area of a triangle is a half AB sine C. So we need to do area of a triangle twice, because the area of the quadrilateral will be a half AB sine C on that, and a half AB sine C on that, which we can now use because that side there and the 7 are the two sides either side of 84. So area is a half times A times B sine 60. Now that'll be a root 3 over 2, so that's just going to be a third. As you can see, 3 sig figs, so you're just going to stick all this in your calculator anyway. If you're not sure, do stick in the brackets, but that all ends up to be 27 root 3 if you did it on its own. But you need to add on the area of the second triangle, so it's a half, and your new A and B, different values, so it's multiplied by the 7 we were given, and the root 117 that we just worked out, times the sine of 84. All that spits out 37.650, etc. And on your calc, all comes to 84.41. So there we go. And on we go. Question 19. Curve, line, what happens? It's significantly harder than normal simultaneous equations. It's quadratic simultaneous equations. And again, if you're out there and you hate these, at least earn the mark for subbing in. So how do you get that? Well, let's write this in a different way. I'm going to write this as x equals y plus 3, adding y to both sides. And now I'm going to take the curve, I'm going to write it out, but whenever I see an x, I'm going to replace it. That will earn you your first mark, at least get that far, even if you hate the rest. So it's 3 lots of x, which is now y plus 3 squared, minus the y squared, which doesn't change, plus the x is replaced with y plus 3. And there you go. At least if you get to that stage, you've earned a mark. But keep going. Try and expand the brackets and ultimately try and form a quadratic equal to 0. So we're going to square these brackets and then treble them. So square the first is y squared. What am I doing? I'm obsessed with that 3. Square the last is 9. Treble it. And times 2 together and double it to get 6y. Treble it. Nothing to do with the minus y squared, but this can now be expanded. Plus y squared. So that makes that bit simpler. And y times 3. Let's get it all equal to 0. So simplify the left whilst subtracting 9 from both sides. And we get 3y squared plus 21y plus 18. You're more than welcome to factorise that. You're more than welcome to use the quadratic formula, but they're all in the 3 times table. So actually it turns out to be a nice, easy one to factorise. Plus 1 and plus 6. And I always prefer, when I'm setting this out, at this point, to split my page we've got y equals -1 and y equals -6. And we've got a nice formula that our x coordinate, to get it, we just add 3 to our y coordinate. So we get 2, and here from the -6, we add 3 to it, and it ends up going up 3 to -3. Not finished though, no celebrations just yet. Yep, you've found P and Q, doesn't matter which order. We now need the midpoint. How do you find the midpoint? You add add the x's together, so 2 added to -3 halved. Add the y's together, -1 added to -6, also halved, leaving us with, you get 1 mark for that, believe it or not, you've only earned 4 up to there, 1 mark for -1/2, and your 6th and final mark for -7/2. Number 20. Arithmetic series looks like you don't know enough. Trust the process. Things will cancel. Things will work out nice. First thing you need to notice before reading on, the first 4 terms. So what they're saying is the first term is k. What they're also saying is you're going down, you're losing 1/4 of k each time. Next one will be 0, and so on. So when you're losing 1/4 k, it means the common difference is -k/4, which you could write as 1/4. There you go. Now we can move on. Given that the 15th term is in the form a plus 14d. Replace a with k. Replace d with -k/4 or -1/4 k. Expand and simplify. You end up with k minus 7k/2. But we can say that it's equal to the 90 plus 2k we were given. Look what we can do. We can do 1 minus 7/2 minus the 2. So we end up simplifying the k to be -9 halves or 9/2. And to work out k, start with your 90 and divide by -9/2. We get k is -20. We can now move on. That means we know that the first term, which is k, is -20, and the common difference is k, or -k, divided by 4. So we need to divide this by 4. So -20 divided by -4 gives us +5. That's for k. Don't forget. Let's move on. So the sum to 30, there's a formula, look it up, get it used. It's n/2 into 2 lots of a, so double your a, plus 30 minus 1 lots of the difference, and the difference is 5. It all goes in your calculator. The brackets works out at 105, so it ends up being 15 times 105, 1,575. Different, yep. Tricky, yep. Not impossible. We've seen worse. Number 21, transformations. Easy if you know them, tricky if you don't, but always try and refer back to what would this do to the sine curve? What would this do to... Now, if you're unfamiliar with them, I'm afraid you're into guesswork territory. They're what you really should be thinking in terms of what does the sine 2x or the 2 sine x curve look like. What about x squared or the x plus 3 all squared graph? That's where your brain needs to be going. That's where your revision should be heading if you end up drawing a blank on this page. But anyway, A is a maximum. Maximum occurs where the brackets are 0. And when the brackets and everything around it disappears, we end up with 9 minus 0. So 9. Part B, what does that translation do? It moves a curve to the right 4 units. What needs to happen is this x plus 2 that's in brackets. When you want to move a curve right 4, you have to subtract 4 from the x part. So x plus 2 take away 4 ends up, the 9 doesn't change, the minus 3 doesn't change, it's this bracket that changes. The x plus 2 take away 4 ends up with x minus 2 all squared. And finally, again, it's either you know it or you don't. Think about what's happened to get to t. The entire curve, the entire function, has been multiplied by -1. There's an x squared. If I multiply it by -1, it does that. If you multiply the whole thing by -1, that, folks, means the answer is a reflection in the x-axis. On we go. To part D, lots has happened here. Again, think back to the sine curve. What does 2 sine x look like? It doubles the amplitude. So when you have this letter A here, the maximum is at 5, the minimum is at -1. That's 6. So where it would be, its regular amplitude has been trebled. So the coefficient of cos must be a 3. Because it's a cos, think about this maximum point here. It's usually there because that's where the cos curve starts. Cos starts at 1, goes downhill after that. So this maximum, it's actually been moved left 90 degrees. So because it's a minus, it's a positive, which you need x plus 90, so it's a minus of a minus. That's horrible, if I'm being honest. And finally, what is C? C is a number that would move a graph up or down. It's a bit like the bottom part of a vector. The top moves it left and right, the bottom moves it up and down. But so does the 9 on the previous one. But this one, in order to move the maximum up to 5, when it should be at 3, it's been moved up 2. 6 marks for transformations. That's quite a lot. Horrible if you don't like them. And number 22. Lots going off here, but not as bad again as it might look. Loads of x's, but you can work it out. The volume of a sphere is 4/3 pi multiplied by the radius cubed. Now the radius is not x, but let's come back to that. Get rid of the pi's. We can now work out r. Do 288, divide it by 4/3, and then cube root it. You get the radius to be a nice 6, but that means that x is 12. Now, before we read on, let's get that onto our onto our rectangular-based pyramid. The height is 5x. It's now 60. This depth here, whatever you want to call it, is 2x. That can go. It's now 24, as can that. Calculate the total surface area of the pyramid. Well, the base is easy enough. It's not where the effort is. Where the effort is the 4 triangular sides. How do you work out the area of a triangle? Well, we know its base. The base of the right and the left triangles is 24. What we don't know is its height. And its height ain't 60. That's the height of the pyramid. The height of a triangle is the length from the base to its vertex, and it's measured along the triangle, not vertical to it or any rubbish like that. So you have to create a right-angled triangle. This right-angled triangle, 60 is on one side. What's on this side? Well, the whole thing is 12, so that is 6. You want the slope. You want the height of this triangle. You need to Pythagoras it. So the distance from A to there, the height of triangle 1 is going to be the square root, because it is the hypotenuse. It's 60 squared and 6 squared, and calc will say 6 root 101, or the decimal equivalent, but I'd rather write the third. You now need to do the same to this front triangle ABC, because that's going to be the height there, which is also the hypotenuse. So you're also going to need to square root and add. Well, 60 is still one of the sides, but this side is not 6. That length there is half of 24. It's a 12. And calc again keeps it in third form, 12 root 26. But you now have enough to do the total surface area. The base, as I've said already, that's easy enough. But now you need to take the right-hand triangle, half base times height, and double it. Obviously, the 2 and the halves will cancel out. So the base of that triangle is 24. The height of that triangle was H1, 6 root 101. We need to add on twice the area, because the front triangle will have a rear triangle, which is identical. So that's also half base times height, except the base is 12 and the height is H2. That's 12 root 26. All that needs to go in your calc. You end up with 2469.4 nearest centimetre, 2469, and we did it without having to use that final space. But there we go. So a few real big ones at the end, some very tricky ones, but again, like always, plenty in the earlier questions. I always think for those of you aiming for about a grade 6 or 7, roughly the first 12 is your real enemy. That's where all the questions are that you get the most marks on. Don't leave any of them out. The next 6 will always contain reasonably easy questions. For example, histograms and cumulative frequency, mixed in with a few that you may or may not like. And if you don't like them, no offence, you're probably more towards the grade 6. Whereas if you're aiming for a 7, you've got to pick up those surge marks amongst others. And then those who are aiming for the grade 8 or 9, you've then got to add in plenty of marks on these last handful, half dozen. If you don't, the 8 and 9 is not going to happen, but don't panic. So it depends on where you're aiming. But as always, not a bad first chunk, not a bad middle chunk, and a few meaty ones towards the end. Anyway, hope that's helped you. See you on the next one.